So it says here, right, in the diagram below, the graph of a cubic function is shown. They then said here O is the origin. Okay, fine. O is the origin. Fantastic. And then they said here R and S. R and S represent the x coordinates of the two graphs. This sketch looks very familiar. There's S here, there's R there. And then it says here A and B. A and B represent the stationary points of the graph. So there's A over here, there's B over there. Okay. And then they said here P and Q are the Y values of the respective stationary points. Oh, okay, I remember this graph so well. I don't know when I've gone through this question, but I've gone through it before. Maybe it was from a past paper.
Yes, probably.
Yeah, because I know I've gone through this before. It looks so familiar. But anyways, so we know Q is a negative number, P is a positive number. And then what that does is, you see we technically have coordinates of A and B. You see B, the X value is on 1, the Y value is a B. Here, the X value is a negative 4, the Y value is a Q. See? So with all this being said, right? They want us to answer all questions. Wait, it says here, all answers may be given in terms of PQRS and the numerical values given in the diagram. So that's good news, you know, one way or the other. But then we can keep on putting coordinates. You see, the X value here is R, the Y value is 0. The X value here is S, the Y value is 0. See? And then, so far, so good, right?
Yes.
Now, for the first question, right, it's a 2-mark question. So we have to know how to interpret these kinds of questions. What does this symbol mean here?
It means the derivative.
Yes, first derivative. And what does the first derivative give us?
The first derivative, do you mean the formula?
Not necessarily. Like, what does it represent? Like this symbol, what does it represent? If you're using an equation. An equation with this symbol will be giving us what? Because remember, f of x represents y values.
Yes.
You see, this represents y values, right? But then what does f prime represent? It represents gradient. So that's what you want to always just keep in your mind, you know.
I'm just trying not to confuse this with inverse.
I answered this one by mistake, sorry. Anyways, so inverse has this
-1 on the F.
Yeah, inverse has -1 on the F. So
with inverse, only the Y, only the X and Y values swap, right? Okay.
Okay. Okay, let's see. Let's see here. The X and Y, what swaps?
The X and Y values, like what changes? Do the signs change or they swap when it comes to inverse?
Yeah, with inverse X and Y swaps around.
All right.
Yeah. And then with yeah, the one thing I was trying to say is that f prime just means gradient. So this is just saying here for which values of x is the gradient below 0. That's what this question is asking. Where is where's the gradient below 0? That's what this question is asking. So for you to determine where the gradient is below 0, right, you need to be able to, what you may call, you need to be able to determine something like this. Like for example, where the graph is going down, this represents a negative gradient. Where the graph is going up, it represents a positive gradient. It's that direct. So you see here it's going down, you have negative gradient. Afterwards, it's going up,
Positive gradient.
positive gradient.
Mm.
And then from there, it goes downwards, meaning you have negative gradient. Oh, put the color of it here already. You see?
Mm.
So let me see here. That's what you need to keep in mind. You see. Let me see here. That's what you need to just. Hello?
Hello?
Yeah. So I'm saying, with this being said, right, if they
Yes.
want us to out where the gradient is, its x values that are above +1. You see?
Yes.
Yeah. So when we give an answer, we're going to say x is below -4, or x is above +1. You see it?
All right.
Yeah, because x values that are bigger than 1, we have negative gradient there. X values that are smaller than 4, we also have negative gradient.
I see. Awesome.
So let me just paste this thing down here where it belongs. So with this, what am I doing here now? So with this next question, right, they want us to draw a sketch. They said draw a sketch on the grid below of the derivative of f, indicating only the x-intercept of the graph. So this is the kind of a question, you see, that needs you to know your theory. But this question also is one of our channel. It's in the applications of playlist. The tutorial there basically shows that if you're working with graphs, right? If you're, for example, starting with a cubic graph, a cubic graph, if you start with a cubic graph, right, and you differentiate it, you're going to get an equation that is a quadratic equation. And then when you differentiate that quadratic equation, you're going to get an equation that's, a straight line graph. So that's how it works. See. So normally, so in this situation, right, we know that whatever f of x is, it's a cubic graph. You see, f of x is a cubic graph. So since f of x is a cubic graph, the first derivative is going to be a parabola. It's a parabola. The reason why the first derivative is going to be a parabola is because if f of x is like ax cubed plus bx squared plus cx plus b, in this situation here, right, let me actually move this. I'm actually move this to the far left. here, if this is what our ax cubed plus bx plus c x plus b, this is our equation, right? If you differentiate
Yes.
this once, you're going to get 3ax squared. If you differentiate this one, it's going to be 2bx. Differentiate this one, it's going to be c. You see that this is a quadratic equation.
I see.
Yeah. So this quadratic equation is what we know we need to sketch. We don't have to sketch its exact coordinates, but we just need to know that first we're going to draw a parabola. Now, the idea with this parabola is that firstly, what you need to keep in mind is, you see that this cubic graph is starting off by going downwards, and then it goes up, and then it goes down. You know, in a situation like this, it tells you that the value a here is a negative value. You see,
Yes.
so if this is a negative value, right, it automatically means that this the portion of our first derivative is also going to be negative. You agree?
Yes, I agree.
So that being said, right, another piece of knowledge that we need to know is that your turning points, the x values of your turning points, these x values of the turning points, right, we know that the gradient here is a 0. Do you see that?
Yes, I see.
Yeah, the gradient is a 0. Now, remember we said that the first derivative is just a gradient equation. You remember?
Yes, I remember.
Yeah. So what we know is in this first derivative, right, this here is basically giving us different gradients. You see that?
Gradients.
Yeah, it's giving us gradients of our cubic function. That's what this first derivative is giving us, gradients of cubic function. Because that's what the first derivative does. The first derivative is just an equation that will give you the gradient of your original equation at different points.
Oh, okay. Just writing down that sentence. All right.
Yeah, bro. Yeah. So from everything that you're saying now, yeah, whatever we're gonna do now, I highly suggest you go through the calculus playlist after this, the one on the main channel, because it has all the things that we may not necessarily be able to say now, but they are like,
Yes, I went through it and made a bunch of notes. So I made a summary on all the calculus formulas to know, all the notes, the do's and don'ts, etc. I went through that whole playlist on your main channel. And so I use the main channel as well as your matric past paper channel as well.
nice. Let's see here. Let's see. So with that being said, right, what you need to remember, um, what you need to remember is the following. What you may call. So what you need to remember about what we're doing now is that this equation will be giving us gradients of our cubic function, yes, but then if you are to sketch this graph, right, technically those gradients will be representing y values of our parabola. You see, because if you're gonna draw this graph on a Cartesian plane, what comes out here will be seen as a y value. You see, so the reason I'm saying all this is because the points where your gradients are as 0, right? These
Yes.
points, right? Like for example, the x value -4 and the x value +1, right? The x value -4 and the y value +1, right? These are going to represent the x-intercepts of our parabola. The reason why they're going to represent the x-intercept of our parabola is because this -4 and this +1, right? What we know is that the gradient at -4 is a 0. The gradient at +1 is a 0. So these zeros here that are gradients for our cubic graph are y values for our first derivative if we were to sketch it. So what we know is because the gradient here is a 0, it means that the y value will be a 0 for the first derivative. Because the gradient here is a 0, it means that the y value will be a 0 for the first derivative. And then we said because this graph starts by going downwards, it means that the value of a is a minus. So if a is a minus here, it means this whole thing here is also a minus, which means that our graph is going to be frowning. So we know that our sketch would need to look like that.
Okay.
Yeah. Yeah.
Hmm.
Yeah. Yeah.
That's a
Yeah.
perfect curve. Oh my word.
Really?
Yes.
Yeah.
I like my things perfect. I just erase and I want it to be perfect.
Yeah. Away. I guess you're in good company. So with that being said, right, this is all they wanted us. This is all they wanted us. So for C is now where we have to do that question that we almost did that time. C said for 2 marks. The equation f of x minus k has only one real root. What are all the possible values of k? So in this situation, f of x is our cubic function, and our value of k is basically just going to be moving the graph up or down. This is going to be a vertical shift. Vertical shift.
Sure.
Yeah. So what you want to recognize though is that because there's a minus symbol here in front of the k, it makes things a bit interesting for us. Because this minus is here, right? It means that if k is a number smaller than 0, it means that the graph moves up. The reason why the graph moves up is because a minus value for k here times this minus symbol here will give you a positive number, meaning you will be saying f of x plus a value. So if you're saying f of x plus a value, your graph will be going upwards. But then if our k value is a number that's a positive value, this in this scenario here, our graph moves down. Remember, this is not fixed. This is all based on the structure of the question. So because this is a minus symbol, right? If k was a plus, it means you'd be saying a minus times a plus, which is a minus. And then you'd be saying f of x minus a value. It means your graph will be going downwards. So that's what we're saying here. If k is a number that is bigger than a 0 here, you'll be saying a positive number times a negative, which is a negative. And in that case, the graph will move downwards. So with all that being said, right, when they're talking about roots are just x-intercepts. You see, roots are just x-intercepts. So us knowing that roots are just x-intercepts, what they are trying to ask us here is, what do we need to do to this graph? How many units up or down should we move it so that this graph has one x-intercept? You see, because if you look at the sketch of our cubic function here, originally, the way it's looking right now, our sketch has 1, 2, 3 x-intercepts. Our sketch has 3 x-intercepts. So, so what you call 1, 2, 3? Those are the x-intercepts. So these x-intercepts, right? We know there are 3. But then if you look at your sketch nicely, right? if this graph moves up or down, right? If this graph moves up or down, it has the potential of having one x-intercept. What I mean is, look, if you move this graph downwards a certain amount of units, you see this value is p, right? If you move it downwards
Yes.
like that, do you see that it will only have one x-intercept?
Yes, I see. All the
Yeah,
others move down. So
yeah.
there's only one exit.
Yeah, if the whole graph moves downwards a space of p units, do you see that the moment it moves more than p units downwards, it's going to start only having one x-intercept?
Yes, which is R and 0.
No,
Or
that
not
does not matter
necessarily.
for now. All I'm trying to say is, I'm just going to show you that if it moves downwards a certain amount of units, it's only going to have one x-intercept. And then if it was from its original place, right, if it's to move upwards a certain amount of units, it will also at some point have what you may call one x-intercept there. Do you see it?
Yes.
Yeah. So we know that there are two scenarios where this graph will have one x-intercept. There's a scenario where it moves upwards a certain amount of units. There's a scenario where it moves downwards a certain amount of units. So because we know that, right? Because we know that, we can now answer our question properly. Because firstly, this is what we're going to do. For it to look the way it's looking right now, right? It would need to have been moved q units. Do you see that? If you move this graph q units upwards, our graph is going to only have one x-intercept. Do you see that?
Yes, I see.
So in terms of giving our answer, right? Our first answer, we are going to need to say k is yeah, this one is going to be a bit annoying. The reason why this question is a bit annoying is because q is a negative number, and but I'll write it out right now and then I'll just explain as best as I can. But you don't want to stress too much about these kinds of questions because these are the like low-key wildcard questions. So here we're going to need to say k is what you may call is bigger. K is bigger than k is bigger than what? Because k has to be, because this is a negative number, right? Q is a negative number, so we have to actually say k is bigger than k is bigger than q. Q is a negative value. If k is bigger than q, then yeah, this one is a bit tricky. So let me just think. Let me see what I'm going to say. The reason I'm saying, the reason I'm taking my time is because remember q is a negative value, right? But
Yes.
we are just interested in the distance between this point and this point down here. We're just interested in the distance that this graph has to move upwards for it to start to have um, one x-intercept. We're just interested in that distance. So that distance is definitely something to do with q. Definitely has something to do with q. We just need to figure out whether we're going to say bigger than q or smaller than q. So we said for it to move upwards, right, k has to be a negative number. Okay. So in this case, yeah, k has to be smaller than q. The reason why we're saying k has to be smaller than q, let me see, k is smaller than q. Yeah, k is smaller than q. The reason why k is smaller than q is because q is a negative number already. So if q keeps getting, if we're thinking of numbers smaller than q, our
Yes.
graph is going upwards. So this one, I'm not going to spend too much time on this, to be honest, because I think this question is definitely a wildcard question. It's not going to move the needle for tomorrow. So that's one portion of our answer, right? The other portion, we mentioned moving the graph downwards. We would need downwards at least p units. So if we're going to be moving our graph downwards here, we said k has to be bigger than k has to be a positive number. So in this case, k has to be bigger. K has to be bigger than what you may call p. K has to be bigger than p, because if p is like 5, right? It means that if you move this graph 5 units downwards, anything more than 5 units downwards, it'll start to have one x-intercept, which is fine, because that's what we are gunning for.
Okay.
Cool. So the next one says determine the values of x for which the given graph of f is concave down. So if the graph is concave down, remember concavity is all based on you have to firstly know where the graph is changing concavity. The graph changes concavity at this specific spot here, because in the middle of the graph, that's where you see that one side is smiling, one side is frowning, and then vice versa. So the side that's smiling is the side that's concave up. The side that's frowning is the side that's concave down. You see? So because they're asking us where's the graph concave down, it means we are talking about the right side of the graph, which is, let me actually give it a different color. Okay. So the side that's concave down is the right side of the purple dot, which is this side here. So because this is the side that's concave downwards, we can answer our question. You see, because look, this is an x value of negative. So the fortunate thing is, all we need to do is to know what the x value of the center is. I mean, the x value of the middle of our graph. And the x value of the middle of our graph will always be the x value that is in the middle of our two turning points, the two x values of the turning points. Whatever is in the middle of the two x values of our turning points, that's the x value of the middle of our graph, which can help us to get the side that's concave up or down. So if this is a -4, and if this is a +1, in between -4 and 1, to get the middle of that, you're gonna just say -4 plus 1 over 2. This is giving you -4 plus 1, which is like -3. Divided by 2 is just -3 over 2. So what we know is that the x value in the middle here is just -3 over 2. See, -3 over 2. So if this x value is -3 over 2, right? It means that the side that's concave down is the side that has x values that are bigger than -3 over 2. So the answer here, we're just going to say our x values are bigger than -3 over 2. Because the portion where our x values are bigger than -3 over 2, that portion is concave down. You see it? You see it, right?
Yes, I see. I'm just writing. Down. All right.